Hello everyone, welcome back to 3 Deviations. In this video, I would like to continue our study of finding areas in between curves. This is going to be another simple example, but we're going to build upon what we did in the last video, just by making it a little bit trickier. Alright, so as a prerequisite for this video, integration rules and the basic idea of finding the area under a curve and between curves. Alright, so why don't we get started with our example. So for this example, I want to find the area between the sine curve and the cosine curve on the interval between 0 and pi. Now, as we get to these harder examples, what's going to become increasingly important is drawing out a sketch of the graph before we make any rash calculations. So there's our graph here. And what I'd like to do now is I'd like to draw the sine and cosine curves between 0 and pi. So the sine curve between 0 and pi is going to look something like this. We're going to have it go up, and it's going to go way back down. And then we'll have a peak at pi over 2. So let's call this here is pi over 2. And the cosine curve looks a little bit different. For the cosine curve, we get something that looks more like this, because that is a shifted sine curve. So that was a pretty bad drawing, but here is pi over 2 roughly. So what we need to do now is we need to find the area between these curves. Now before we just say, oh yeah, well we're just going to do sine minus cosine, integrate that, well, we need to be a little bit more careful. The area that we're trying to find is this area in here. Then we're also trying to find this area in here. So we're trying to find those areas. So what we do is we're actually going to separate this into two integrals. And what's going to be important is that we remember some of our trig unit circle values. So right now we need to determine this value here. Now this is where the value of sine and value of cosine are similar or are equal on the interval between 0 and pi. Now where are they equal on the interval between 0 and pi? And it's before pi over 2, so between 0 and pi over 2, where are sine and cosine equal? Well, they're equal at pi over 4. So at pi over 4, our sine value is root 2 over 2, and our cosine value is root 2 over 2. So now we know that that's where we are going to break up our integral. So we're going to find this integral here, then we're going to find this integral here. And on the left side, we will be subtracting sine from cosine, because sine is on the bottom here and cosine is on the top. And then on the other side, we will be subtracting cosine from sine, because cosine is on the bottom and then sine is on the top on this interval. So now we're ready to set up our integral here. So now we know that the area that we want to find is going to be equal to the integral between 0 and pi over 4 of cosine of x minus sine of x dx. So that's this first little chunk in here, plus the integral from pi over 4 to pi of sine of x minus cosine of x. So that's this area right here. So now all that's left to do is to integrate. So now these are these are the two most simple trig functions. So what we can do is we can just integrate these, and we know these antiderivatives, so now let's just plug it in really nicely so that we can deal with the fundamental theorem of calculus later. So that's going to give us the area is equal to sine of x, because cosine goes to sine, plus cosine of x, because our negative sign goes to positive cosine. And then that's going to be evaluated between 0 and pi over 4. And then we're adding that with the negative cosine, sine goes to negative cosine, minus sine of x, because our negative cosine goes to negative sine. And that's evaluated between pi and pi over, or between pi over 4 and pi. All right. So now let's remember our values. So when we plug in the fundamental theorem of calculus for both of these parentheses here, we're going to get root 2 over 2 plus root 2 over 2 minus 0 minus 1 plus 1 minus 0 plus root 2 over 2 plus root 2 over 2. So those trig values really do stick with you in calculus. All right, so if we just simplify that out, it becomes fairly simple, fairly straightforward. That just is equal to the value of root 2 minus 1 plus 1 plus root 2. Then the 1's are going to cancel out, and we're going to be left with 2 root 2. So the area in here is equal to 2 root 2.